This video is on solving logarithmic equations. So basically a logarithm involved into an equation. The first process here is if there's only one single log, basically one occurrence of the word log, then we're just going to simply change the form of it and solve. So for example, in this first one, we have log base 2 of 2x is equal to 3. You can see there is only one log here. So if I change the form, starting with the base, it'd be 2 to the third power is equal to 2x. So if I write 2 to the third is equal to 2x, simplify what I can. I know 2 to the third is 8. Divide by 2, and I will get x to be 4. And if you plug that back in, that will check. In this next example, again, one single log. Start with the base, make my spiral. The base is 3. The exponent is negative 2 equals 2c. 3 to the negative 2, remember reciprocals, will be 1 over 9. And then I'm going to divide by 2. And I'm going to get c to be 1 over 18. Next one here again, one single log. So I'm going to have 25 to the 1/2 power is equal to x over 2. Remembering that 25 to the 1/2 power, the 1/2 power is the same as the square root, so that is equal to 5. And then to solve for x, I would multiply both sides by 2, and I would have x to be 10. Next example, again, the base is 4, the power is 2. So I'm going to have 4 squared is equal to 5x plus 1. 4 squared is 16. I'm going to subtract 1, divide by 5, and I'm going to get x to be 3. Here the base is a variable, so I'm going to have x to the third power is equal to 1,000. To undo that third power, you could do the cube root of both sides. And the cube root of 1,000 is 10. And the last example in this form, the base is 8, the power is 2. So I'm going to have 8 to the second power is equal to 4x plus 4. 8 to the second is 64. Going to subtract 4, and I'm going to get x to be 15. So in all these, we have one single logarithm, and we're just changing the form of it and then solving the equation. Now, if you've got multiple logs, so more than one log written in the equation, if the bases are the same, you can get them on the opposite side of this equation, then basically you can just set them equal. So in this case, you can see we've got log base 2 and log base 2. So if they're equal to each other, then these must be equal. So I would just set the x plus 17 equal to the 3x plus 23. And solve, I could subtract x. I could subtract 23. And get x to be a negative 6. Or 2x to be negative 6, so x would be negative 3. Again, checking this, putting it back in, we just got to make sure that we're never taking the log of a negative number, because that's not possible. And in this case, it does check. Here again, same base, they're set equal. So I'm going to set 3x minus 1 equal to 2x plus 3. I could add 1, subtract 2x, and I'm going to get x to be 4. Plugging 4 in, you can see you're going to have log base 4 of 11 on both sides, so that does check. Last example, they're both base 6, so I can set x minus 3 equal to 2x. I I can subtract the x. I'm going to get x to be negative 3. If I plug negative 3 in here for x, you can see I'm taking the log base 6 of negative 6, which, again, is not possible. So therefore, these solutions would not check. There'd be no real solution for this one. So in summary here, when you're solving a logarithmic equation, if you just got one simple log in there, one single log, just change the form of the equation and solve. If you've got multiple logs, you're going to want to get those on each separate side of the equation. If the bases are the same, you can just set them equal.